let's get started. So we're going to number the classes as if when you have a substantial thing to do over the weekend, as you did this time, that counts as a class when you watch me talk on a screen. So we'll call this class 4, even though this is the third time we get together. And last time we were together, I suppose this should be penultimate class if I'm numbering the other one, we talked quite a bit about what is a note. Right? And let's just take a second to review, because there were a couple people who weren't here on Friday. What are some of the things that are complicated when you're talking about what is a note? Quick hand and shout when it's quiet. Or just.
Does it need a pitch? Does it need a duration?
Does it need a pitch? Does it need a duration? Great. What was the problem when I went da?
You couldn't tell if notes were slurred.
You couldn't tell if notes, not so much slurred, you can tell, what's the other word he's looking for? Tied. Yeah, because da, that could be 4 tied notes, right? Depending on if we think of the notation as one domain, as our definition of the note, or if we think of what we hear as a domain. Good. Anything else that's screwed up our easy conception of what a note is? Remember, or make up your own? We had 14 notes in a glissando. We had yeah, go ahead.
I forget what it's called. The term where you like.
Well, sing it for us.
You have 2 notes and then you have to kind of oscillate between the 2.
Yeah. What was that called? Somebody else? Yeah, John.
Trill.
A trill? Yep, trill's one of them. And the other one that we talked about was, yep.
Tremolo.
Tremolo. How many notes does it take to write a trill on a standard score?
1.
1. How many notes does it take to write a tremolo?
2.
2. How many notes are there in a trill? Whole gob, right? A lot of them, as many as you can put in. Yeah, so these kinds of different representations we did a lot on. Today we're going to be talking more about not just what is a note, but how can we represent a note, or how can we represent something else for a computer. You know what? I made really nice handouts that I put online and forgot to put them out, so I'm going to keep one for myself, and we'll try to do a group here going this way, a group here going this way. And in the back where I see people the least, I see the fewest name tags. So if you don't mind, I'd really like to get to know everybody by name. There's some discussion of various configuration problems and a few solutions and a few things still left unsolved. On Canvas, if you'd like, stick around after class, and we'll talk through some of those things. And there was another question, who raised it, Hannah? No, about whether or not the standard library is okay. So the standard library, and that includes things like math and regex and things in Python that some classes don't let you import. Yes, if it comes with Python when you download it, you may use it on anything. So I'll unlock the entire standard library. So go ahead and import math within the math library. Some people saw that there's a particularly useful function in the math library. What's that?
Log.
Log, yeah. The log. When you're dealing with frequencies and things, you'll see that the logarithm function. So if anybody re-implemented the entire logarithm function, we can talk about getting a life rate. No, you did great. Super, we can give extra points on that. But yeah, if it's something that you have to download via pip, then always ask beforehand. But I do want to say, at the end of the semester, when you have final projects, it's anything goes. So if you can find it on the internet, or you can build it, you can use it. Okay, we're going to start. We're not as talkative as we were on Friday. Friday we were very, very energetic, so maybe we'll start with talking amongst ourselves. I want you have 1 byte. How many bits are in a byte? 8, good. So you have 8 positions where you can have 1s or 0s. And I want you to try to encode pitch and duration. So the two things that in one representation, one definition of a note, are two of the fundamental parts of it. I want you to try to encode a note in 1 byte. And then talk about what kinds of things you've had to decide you're not going to represent in order to make that possible. I'd like you to do this in groups of 2. So it's very, everybody is either at a desk with somebody else or not at a desk with somebody else. So if you could just make that the group, and we'll give it about 3 minutes. Okay, let's come together and let's see. We started middle of the alphabet last time. Who's a group involving somebody with a name toward the end of the alphabet? I don't think we have any Z's, X's, Y's. Vanessa and Adam, either way, I had started this. You guys would be going first. What's something that you decided to encode, and what's something you decided to compromise on?
I think we decided that it was more important to like preserve information about pitch than it was to preserve information about duration.
Okay, so that's always a choice. So we're going to have a lot more information, or all the information, on pitch rather than on duration. Good, so we have to make a compromise that even though I said these two things, maybe one of them is more important than another. Great, going alphabetically backwards. Oh, we should have started with Vincent and Jake, sorry.
Yeah, I think what we decided first was that, like Vanessa's group, pitch was most important, and so we decided to like prioritize encoding like the 12 discrete chromatic Western pitches.
Okay, so we've decided to limit to Western pitches, which is already a compromise, losing all those great microtones, and we said we want 12 of them. Great. How many bits is it going to take to encode 12 distinct things? Let's do fingers. Good. I see a lot of 4s, because why is it 4? Somebody explain. Anyone want to? Yeah, Jordan.
2 to the 4 is 16.
So 2 to the 4 is 16, and what's that have to do with 12?
You can have that many like combinations, I guess, permutations.
You can have that many permutations into there. What's 2 to the 3rd, everybody? 8. So it's sort of, that 8 is less than, is less than 12, is less than or equal to 16. Therefore, we need 2 to the 4th. So we need 4 bits for that. So we have 4 bits in one thing for pitch class. Is that a term that everybody knows? It's not a term taught in all of 301 first semester theory. It's, I'll just say sort of encoding C as 0, C sharp or D flat as 1, D as 2, or also I suppose C double sharp or E double flat. We don't really care. So we're going to use 4 things for pitch class. Something like that, great. And anybody else do something like this? Any other groups? Jason and, okay, so quite a number of groups. Let's see, we'll go with Phil and Angelica's group. What did you do with your other part?
We try to like split it up with duration, so we'll like sacrifice the like octave pitches. And just encode the duration with the rest of it.
So how many durations can you encode with what's remaining? 16. What are some durations that you might have chosen to encode? Or we'll move on to Lila, and John.
We could do like whole notes, half notes, dotted quarter notes, etc.
Whole notes, half notes, dotted quarter notes. Explain a little bit more of your etc.
Oh, yeah, so you could have like your basically like whole, half, quarter, then you like add the dot because we have 16 bits to work with.
Okay, whole, half, quarter, and
Like
eighth. And so how many bits is it going to take if we just stop there? Only 2, because we have 2 to the 2 squared is 4, right? So we can put that into there. And then if we want to encode if it has a dot or not, is that another bit? So then we have dot or not. What happens if we say, we just put one more thing in. We'll put in 16th. What do we get as the problem? Can we squeeze that into 2 bits? No. So once you decide that you're going to be able to encode 16th, you might as well go and do your 32nd, 64th. Do we want to do 128th or breve? Double whole note. They're both pretty uncommon. So we're slightly wasting some space on some pretty uncommon things, but we get the dot. So that's 3. Yep.
Think about doing just 16th notes as your base, and then you can have all like multiples of 16th.
Okay, you can have multiples of 16th. So you have 16th as a base, and then
If you had like the number 2 or 1, I guess you'd get like 0 would be 1/16th note, or I guess, or maybe not. Maybe you'd want to be able to have 0 time, but if you had 0 as 1/16th note, then 1 would be 2/16th notes would be an 8th note, and then you could do like dots and stuff, and you can do all of that stuff.
and you can encode up to something that has 16 16th notes, right? With that way, which would be a whole note. So that's pretty great way. It does mean we are spending quite a bit of energy dealing with things that are a little bit unusual, but yeah. Anybody have any ways that we didn't talk about very much in this? Yes. Yeah.
We thought that it was important to encode octave information too.
Uh-huh.
So we spent 6 bits encoding like the 64 of the MIDI note numbers.
Okay.
And then 2 bits on duration.
64 MIDI notes. So now we have octave. Good. 64 out of the 88 keys in the keyboard. You just decided to do just the outside ones, right, and leave out the ones in the middle. Okay, good. And then 2 bits for duration. So we get maybe whole, half, quarter, eighth. Not too much more. Great. Super. This is a great thinking exercise. Why might you want to do that? Well, there's some people who use. Oops. That's the most confusing slide in a while. There are quite a number of people who are very interested in not even 1 byte, but 6-bit encodings. And for instance, in the Braille music code, one of the important things is being able to encode the 7 diatonic notes, because the diatonic notes tend to be used much more often, and maybe somewhere else you have something that tells you the key signature. The 7 diatonic notes and 8 durations in 6 bits. How do they do that? How do they get 8 durations? They've doubled up and said, look, if you're on a 128th note, you're really unlikely to move to a whole note. So that contextually, you take advantage of the fact that it's very rare to have a whole note and then a 64th note. And if it's really, really, really unclear, fortunately, they put in a space, the Braille music code, it puts in a space where there's the end of a measure. So if you're really unclear, like, I wonder if these are all 128th notes. No, the measure ended. Okay, they're probably the long notes. So that's one reason why you might be thinking of very efficient encoding. Many things are lost there. We'll take, I don't want to spend as much time on this, but get back in your same group and talk about what you could do if now you had 3 bytes on average to encode your notes. So that if we have a typical score, and I'll leave you to think what a typical score looks like, that you could be doing. Sometimes you take a little bit more, sometimes a little bit less. So just talk through. You don't need to come up with a full representation like this for it, but just what are some of the things that you might add? Okay, let's come back together. What are some things we use this enormous bounty of space of 3 bytes to do that you didn't do before? Let's just go around, and you can say pass, but we'll start over here in second row and go I guess left to right.
Then we say the octave for the kids.
Okay, great. We've stopped leaving out octave for everybody, right? Another group.
Dots.
Dots. Okay, we have dots in here. Great.
Got articulation.
Articulation, ooh, yeah. Does every note need an articulation? No. So this is where average might come into play, right? You might have something, some sort of a flag somewhere, some condition that says more information to come, and then you can use the additional space. Great, articulations. Other things?
We said maybe like dynamics or volume.
Dynamics or volume? Mix, volume. Just in case I forget to mention it at some point, a lot of people in the computer music world call the dynamics of volume the velocity, which really tells you that the piano was the first instrument they were thinking of encoding, because it's how fast you hit the note. How fast you hit the key on the clarinet doesn't really make it any louder. But velocity, dynamics, volume, velocity. Good. Continuing on.
I guess you could do something like what you just said for the flag, where like if it's an extreme range of a note or extreme duration, then you say like, oh, this is an unusually long note.
Extreme cases to follow, right? Or something like that, to follow. And yeah, so that could be, these could be little flags. I suppose. Do people think flags look, yeah, flags look better going left, don't they? Good. Other, continuing around, other things to chose that aren't on here?
So I think one thing was, I guess, like time signature and stuff, because
Ooh.
It encoded with like just the reference of the musical half note and quarter notes.
Yeah.
Information isn't necessarily stored within the.
I actually made, yeah, I put in and anything else on this slide that I didn't put on the other one because, yeah, I thought maybe time signature could go in, key signature, other things that go at the beginning. What else comes at the beginning piece? Shout out.
Key signature.
Key signature, time signature, tempo.
Name of the piece.
Name of the piece, metadata. Name of the piece, metadata, very important. Who wrote it? Date, metadate. Sorry, that was yesterday's metadata, now metadata. Yeah, clef. Good. Quickly go through the front row. If you have something that you'd like to throw onto this, we'll continue. Was that, Adam, did you guys just spoke, right? No. No, did you? Because you shouted out when I said anything else you put in your encoding, Vanessa.
Say like whether or not spin is part of it.
Ties, good. That lets you build a lot of things. Jordan and Misha, anything? Triplets. Yep. Triplets. Yeah, I was just. What's the generalization of triplets if they're not 3? Anyone know? Term for tuplets, or more often tuplets in the British pronunciation, tuplets more often in the English pronunciation. Good. Anything else? Why would we want, and so here's some examples, by the way, of how the Braille code uses an average of 1 byte, but allows for, or 1 cell, 6 bits, but allows for other things. So if we have accidentals, we can be adding particular marks to say, hey, there's going to be something else coming next. Look up what this extended mark is. Or sometimes there is a sign that you can use for saying, hey, I know you'd think that I'm all in 32nd notes and I'm probably going to jump to a 16th note, but actually I'm going to jump all the way up to a half note or something. So there are some cautionary signs for that. And beams and things of that sort can be put in. Yeah, Adam.
Is there a Morse code for music notation?
Morse code. Not that I know of. Not that I know. The Braille, by the way, music code predates the Braille text. Louis Braille invented the music code first and then decided to do it with text before, in part because text is already a little bit easier to read with raised impressions, whereas music was just impossible to read with raised impressions. So there was more of a need for reading music than there was for text at the time. And just for a second, let's just think, what could you do that you couldn't do with this if you had about a megabyte per note? Well, that's 1,000,000 bytes. People have thought of this all the time, and you've probably done it, and you're not even thinking of it. You've probably used a megabyte encoding per note already today. I know that John has. Just.
So I see. We could have like different like features for like the output of the notes, or like whether it's like stereo or mono sound.
Stereo or mono sound, or yeah, you're getting yeah.
Fidelity.
The fidelity, just the audio wave of the note. You can encode the exact, why do you need to encode, is this a C sharp or something when you can just hear it? And you can also be encoding with that, the fidelity, the mono thing. You're encoding the exact instrument, how it was performed. You're losing generality, right? Because you're encoding one performance of a particular piece and not every performance, but maybe you can do 1 megabyte plus an average of 3 bytes to also store what the note was supposed to be. So we'll be able to get the best of all worlds. Okay, what do we have? Why do I care about efficiency? It's in part because we're at a point where we can start storing a lot of information about notes. Most of us don't bat an eye anymore at the notion that we're streaming in high def or 4K or whatever, and gigabytes of billions of, did I say billions before? I meant millions before. Billions of bytes in an hour just to watch a movie. So why do we care about if we can store one extra thing in the note? It's because almost entirely based on history. This is one of the earliest encodings of a musical piece. The dissertation is from 1982, but this is going in the 60s and things. And we started with punch cards. And punching cards takes a long time. So the more efficient you can get with your encoding, the fewer cards you're going to need. And this has left consequences on us for today. By the way, I always thought that, punch card, you can, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you get 10 bits of information. It turns out you punch too many holes in a punch card and you try to put it through the punch card reader and it jams. So you actually have a limited number of ones you can do per byte or per row in a punch card. But we're still having to deal with some of the choices that were made in order back when computers might have 4 kilobytes of memory or 16 kilobytes of memory for every single thing. So if you want to store 16 kilobytes of 16,000 bytes, if you're storing 10 bytes per note, you only store 1,600 notes. You can't get through a whole piece. But if you can get it down to 2, matters. And so we have a lot of ways that are very compact representations that are still out there, and that we're only over time feeling like, we can expand a little bit. This is your first file, your first encoding format that you've seen in this class, I believe, right? Besides stupid, weird ones I make up on the fly. This is called Muse Data. This was one of the first major projects of encoding a lot of music into things made by Walter Hewlett of Hewlett-Packard fame. And let's try to guess what some of the things might be in this. Let's start with something really obvious. What do you think this means? Rest. Okay, good. We're obviously already in a period where we can afford 4 bytes to write out rest rather than putting R in. So this tells you that this is a little bit later than other things that were happening. Somebody else take a guess what something else might be. Yep, go ahead, Joe.
Does Q stand for quarter?
Q might stand for quarter. Let's see, we might find something that will help us with that. I'll go easy. Measure stands for measure, and measure stands for measure, and 1 stands for 1, and 2 stands for 2, right? Is there anything that would let you think that q cube in one measure might be the right thing? Yeah? John.
T for time signature, probably.
T time signature 3, 4, right? Everybody's notation teacher always told you never put a slash in a time signature when you're writing on the page. Well, in computer stuff, we always do because we have nothing better to separate them. Good. Q's that. I think these are notes. Good, good. Interesting thing is that they end up encoding the duration twice. Since this one, I've tried to do this a long time. What do you think that is? And it's almost impossible to get. So you have the quarter note, and you also have something that says a quarter takes 2 somethings, ticks, maybe, some things like that. And so you encode it twice. Once, what's the difference between this 2, each quarter is 2 of something, and that this is a Q? Who needs what for what? Yeah?
What's printed on the page versus what's played?
What's printed on the page and what's played, so that you don't need to convert between visual and time duration. And this is a function on almost all modern storage things still today. It's also helpful for, there are some very weird cases that you'll run into in one of the readings later where composers have used durations to mean something slightly different from what they generally are. Okay, so this is some of the reasons why we went through efficiency. You're going to be on the second problem set, the one that you'll get on Friday, which will be done in groups. You're going to be coming up with your own representation system for some sort of thing that is music, except for the thing I'm just about to talk about, common Western music notation. So something else besides normal scores that we see all the time. And you'll need to make the same choices, decisions, mistakes, maybe, that pioneering people did in the 60s and 70s, and hopefully learn something about what trade-offs happen along the way. So we're going to be talking, oops, the slide's a little bit out of order. This should be here. This slide should be about something in the class which is called common Western music notation, often abbreviated to leave out one word, one letter, either common Western music notation, common music notation, common Western notation, some things like that. This is an example of what I think most people would believe is common Western music notation. It uses notes, staves, clefs, things. Left to right means earlier to later. Up to down means higher to lower, right? So that here's a whole bunch of high notes and here's a whole bunch of low notes, right? No, except for that there's certain things that we say only within a particular staff is higher and lower, and then we have divisions and we move on to other systems and stuff. So yeah, so these are things that are standard in common Western music notation. That was a piece by Joseph Boulange, the Chevalier de Saint-Georges. This is a piece by Clara Schumann, her piano trio, trio for piano, violin, and cello. And you see some things that we consider to be common Western music notation, including slurs, ties, grace notes, beams, all these types of things. Common Western music notation can represent a piece of music in multiple ways. This is an aria from Wolfgang Mozart's opera Don Giovanni, an aria song, in that Ai chi me dici mai by Donna Elvira. And we have the top of each of these systems, voice part, Italian translation to English, two staves for piano. And then the exact same music in some way. Here's her part, here, except for the English is gone, very helpfully replaced with German. And her nice treble clef was nicely replaced by soprano clef for ease of reading for all of us because she's a soprano. And the piano is gone, replaced with, take a guess. What are these parts for? Orchestra. Yeah, so we have strings, we have other things going on. One of the questions would be, when we have multiple representations of the same piece, how do we translate from one to another? Is there a way that we can go from this exact moment to that exact moment? And what kinds of relationships would make that possible? So jumping back to Clara Schumann's piano trio, there are some things that violate particular norms of common Western music notation, such as, well, I mean, they're part of it, but they violate the basic principles. What are these things up here? Grace notes. Let's say a quarter note takes 1 tick, a half note takes 2 ticks of some sort, an eighth note takes half a tick. How much does a grace note take? Yeah.
Usually half the allotted time.
Usually half the allotted time. So if I put that's very true in one sense. So correct, absolutely correct. It's also not true in another sense. So if I have 4/4 and I put in a dotted half note, and then I put in a grace note, well, that takes half of that, so it's 1/4. So I still have enough room for that amount of space, right? Can everyone see from back here? That's a dotted note. What's wrong with this representation? Adam?
The grace note also eats away at the actual time for the note.
The grace, yes, so the grace note steals time from the note that it's next to, or it steals it sometimes from the one before. So in terms of how many grace notes can you put in a 4/4 measure? Let's put it this way. Is it a trick question? 16? No, you can put as many in as you want, because the grace notes just steal time. So for instance, here we're in 6/8, so we have 2 dotted eighth note beats, and we have a dotted quarter note. And so we have a dotted quarter note here, and the equivalent of a dotted quarter note here, and we can squeeze in 5 grace notes there, 7, 8, doesn't matter. But where conceptually do you play that? And if we have this notion that in common Western music, everything that happens at the same time is vertically aligned. I hope your theory teachers taught you that. That's the most important rule in general. How do we know where to align these notes with the grace notes? So that's one violation thing. The limits of common Western music notation are not strictly defined. This is a very common genre of music from around 1700, 1687. Elizabeth Claude Jacquet de la Guerre. Very interesting piece. A lot of things that look like common music notation until you start getting, what is this? What are these? All the symbols of common Western music notation, but used in a different way. These are unmeasured preludes, so certain places that should be played in time and certain other things that most people believe these tell you play these notes for exactly how long you want. I kind of figure some other people think maybe improvise something on those notes, but it's common Western music notation, but it becomes a problem for the computer. What's the problem for the computer? When it's all handwritten. And so there's all kinds of ambiguity. You can tell that, okay, this is going, and that's an A, and that's an A, and that's an E, and that's a C, and that's either a D or an E, right? We can conceive of a note that is hard to read. Does your representation have a way of notating that. So musical handwritten scores also tend to contain lots of things that violate common music notation. I saw a Beethoven manuscript once where he was just going along on 2 staves. Then it became obvious that the top part was just going to repeat. The bottom part was just going to repeat what it was doing. So goes along and just uses the top one. Next time he's drawing the next system and he needs another staff. Oh, and there's this empty staff above. So he goes ahead and uses it. So you can be jumping forward and backwards in time in the same thing. There are almost every composer of significance has made their own tweaks to common music notation. This is by the 20th century composer Igor Stravinsky. Later in his life, he started to ask, why do we, when you have instruments that don't play very much, why do we waste all the staff putting them out? So it's really easy to see what's resting if you just start the staff where they come in and end it when they end. A little bit there. Limits of common Western music notation come out in certain pieces. This was, I think, my freshman composition assignment when I was trying to be a composer, where I've used some things that look like normal notes, but then at this point, I didn't want to calculate what the tempo was, so just hold it for about 2 seconds, hold this for about 2 seconds, and then get to this point, and this part should accelerando, so we'll just show about how kind of end like a 64th note is that part of common Western music notation. It wasn't 50 years ago, but there's quite a number of scores that do it now. A lot of the music being written today are stretching common Western music notation quite to the limits. This is Kate Soper, who was a Pulitzer Prize finalist a few years back, teaches at Smith College. One of her pieces from part of Ipsa Dixit, her opera, she herself said it, where moves back and forth in the voice between sung and spoken and uses these other symbols to tell you how much to open and close the mouth. And something a little bit odd about the violin. Lots of things odd. I'm thinking about the staff itself. It's not a usual clef for the violin. Now, we have a violin in percussion clef with 4 lines. What do you think those 4 lines represent? What does the violin have 4 of?
Strings.
Strings. So just what string to play on. You'll figure out the notes. This is a piece by Brian Ferneyhough, part of a compositional group called New Complexity, which, if we look just at the first measure, there's almost nothing that violates common Western music notation principles that we learn in our theory classes, but they tend to take it to the extreme. So, for instance, the first measure is 2/8, where we're going to put in place of the 4 16th notes of 2/8, we'll put 7 16th notes in. Within that, for most of these, we're going to put 21 32nd notes in the place of the first 20 of them, or 24. And then within that, we can have triplets, so that tuplets can be nested almost indefinitely, and there's no reason why our time signatures have to be powers of 2. So people are playing with things like, okay, Professor, stop talking about the weird music. This is all strange new music. It's nobody in the great past, like Mozart, would do things like this. So we go back to Mozart. This is, again, Don Giovanni, the end of the first act. It's a very cool moment. If you don't know the opera, they go to a very, very rich ball, and it's kind of like going to a club today with multiple rooms and multiple people, DJs or whatever, doing things. And so here at this big ball, we're going to have in one room in 3/4 a stately minuet for the upper classes. They like their 3/4 dances at the time. And then in another room, we're going to have a dance in 2/4 for sort of the middle class, because they like those things. And then for the farmers and things, we're going to have, they like their Chivaltine 3/8, 6/8 dances. All together at the same time. The bar lines. When you say, well, let's start at measure 22. You go, I'm sorry, my measure 22 or her measure 22? Because you don't have a concept that measures are universal. This is, I think this is, this is Ravel or Debussy. I think it's Debussy, Le Danse d'époque. Very, very common. Everything looks great. Everything looks great until, what does that mean? We're in treble clef and treble clef, but we have a bass clef just for this one note. Does it also go here? No. You can tell what this is, what that means. Just better not to write a whole nother staff just for one note, right? But you can have two clefs simultaneously on the same staff. You can also, there are examples from Bach of two time signatures in the same staff, or changing time signatures mid-measure. And what does that mean? So almost every composer has pushed the limits in some ways of conventional music notation. Jump back to Clara Schumann one more time. There's certain things that might be very obvious to us, but that can be very difficult for encoding in such a way that it's completely unambiguous for a device as stupid as a computer, such as, where in the measure does this begin? You all are musicians. You all know that this line is continuing up to here. And that's why there's something empty here and empty here. But how would you teach a computer to make that kind of abstraction, that lines can move from staff to staff and therefore don't need to be filled in? So any questions on this? Sorry, on any of these things or any discussion points? Adam, we'll start with you.
What is that rest supposed to mean right there?
What is this rest? This.
So at the beginning of the menu, there's a peak.
Oh, this one here. This is because your professor did not print a PDF, but took a really fast screenshot from Finale. And so it's even a new thing that our user interface. So this is the user interface that says, this is a hidden rest until we get to this note that has to be added onto here. Super great. No one's ever seen that. But yes, the user interfaces also end up being part of our conception of notation today. Good. Other points or? So where does common Western music notation end? Where do other things go? And and what might we want to represent that's not common Western music notation? So this is a type of thing I work on from time to time. This is church music from I think the early 17th century or late sometime late 17th century maybe, and looks very much like ours, but just the note shapes are a little bit different. Common Western music notation, just with a little twist, maybe, not sure, but it's not too far off. All of our notation goes back and back and back in time, or it has come from decisions we made before. Let's start with, this is Western music notation. This is the first music notation of Western Europe from about the 9th century. This is the chant for the Mass on Christmas Day. And what these things do is they tell you how many notes there are, and if they go, in this case, 1, 2, 3, and they go start low, go high, come back down. About the same. Higher note, same thing. We have up, down. Most of these go up and down. Here we have 1, 2, 3 notes going down, 3 notes going down. The height means nothing. It is music. Might we want to represent this, and how might we want to? And some of the things people are always wondering, we have pages and pages and pages, thousands of pages of music in this notation. How is it helpful for somebody to know how many notes to sing and whether they go up and down, but not what notes they are? Right? So that's something a lot of people got. Wish we had met yesterday, be a little bit more obvious. This is a piece from around 1420, Baudecordier's piece Belle et Bon Sage, in the shape of a heart. There's something about the shape of the piece. Is that something we want to represent when we're making our representations? About the same period, it's a piece in the shape, instead of a heart, shape of a harp, hard to say, where it's basically the music notation of its time, except that it's sideways, but we're writing it on the strings, so we need twice as many strings, and we don't write anything on the spaces. Getting back to more modern music, some of the things that definitely violate almost every principle of common Western music notation, but use some of them. This is Cornelius Cardew's piece Treatise, which uses a lot of notational symbols, a lot of things that look like music notation, but it's up to you to interpret them, done differently. Every group performs this quite differently. If you're going to have a graphical score where you use music notation elements, but they don't mean anything, maybe a musical score doesn't necessarily need to have any elements at all. Earl Brown's Folio from December, December, what is it, 1962. That's all things that have come out of the West. Japan, China, many cultures around the world have developed their own notational systems. And then there are notational systems that have been made to try to study the physicality, in this case of Inuit throat songs, without using anything that might have the cultural baggage of Western notation. So we start notating the actual, the spectrograms. Is that a form of music notation? And if so, how would we do that? One more of tablature. Just giving a sense of some of the notations that might be happening in the world. In addition to notations that have been sort of created over time by people, there are invented notations that have been found to be very useful times. This is something called TUBS. If anybody has taken the time unit box system, I think it was invented around the 1970s. I'll look up exact time later. But the notion is kind of like I did with the bits, things that you can specify what the smallest tick you want to notate is and specify when somebody plays. Or if you need to specify different things they might play, you can put that in the box. This has become a very useful and used system, especially in the notation of West African music. Lots of notational system representations have been created, many of which have not been successful. This is the turntablist notation system because there's nothing that's greater and cooler than spinning at a bar while reading music notation, right? But it is a way of notating what somebody did for reproduction later. Let me see if my sound is working before doing this. I'll be very disappointing. I should have checked that ahead of time. Give me 1 second.
What is it?
So, but not all notation and representational systems end up being very successful. I think this is super cool. I don't know why I made a joke about it. I think it's really innovative. The website has been down for about 6 years now, so I assume it did not take off. One of the earliest mechanical notational representation systems that's still very influential is the player piano roll, or we just call it the piano roll now, where the actual punching of the notes on the staves becomes a very important part of how, it encodes the notes. So we get, again, the same kinds of notions of up and down, though side and side for height. I guess sort of height turns sideways. And as the roll progresses, there's a cursor. There's this technical name for it. I can't remember it in piano rolls. That is reading at that moment what should be happening or what is happening at that moment. There are other ways of controlling, usually on the side, what the dynamic of the entire piano is, but usually not of encoding what the dynamic of any individual note is. And quite often, written along the side, though, there will be the lyrics of the song written kind of like when you're driving and it says like, slow crossing, pedestrian crossing, read upside down, so you learn to read it that way so that you can sing along with what the piano's playing. Very cool multimedia. Questions about things going forward, or discussion, or just things that you're thinking about? Because you're going to be thinking about something to represent that isn't common Western music notation over the next week. Yeah, Adam.
That abstract painting that you showed of the notes, that reminds me a bit of Line Writer.
Line Writer. Oh yes, the game where you're writing on you draw all the things and then you get to see how the motorcycle jumps around. Is that one? Yeah.
Some people have done compositions in which Line Writer motions are synced to a piece of classical music.
Very, very, very cool. Nice. Yeah. I want to see that at some point. Yes.
Is this just kind of like a big music box?
Yeah, it is, but often something that you could also attach to your home piano, so that you have your home piano early on, and then later they become, or I might have my chronology reversed, but then they become sort of things that become standalone objects. But there were things that allowed people to feel more like they were playing the piano by having you pedal it and control the volume, so that you could do and control certain levels of softness, kind of like using a Betty Crocker bake mix to bake your cake. You get a feeling that you really did something to make the music, but not the really hard parts. Yeah, cool. Yeah, these are interesting. We have some of these over at the Lewis Music Library, which I'm going to be talking more about later as we go into representation things. But the Lewis Music Library, just over here, has put as one of its sort of long-term visions to try to get all of the different technologies that have been used to encode and playback music over time. So there's wax cylinders and piano rolls and stuff, and reel-to-reels, and trying to make it so that there's some that are very valuable and need to be preserved, and some that we can just play with, and you wouldn't want to have a problem, but if you did end up breaking the reel tape, it's okay. We got more. Yeah. So definitely, if you haven't been to the Lewis Music Library, check out what they have there. They also have a theremin if you want to play with that. And you might be using them at the end of the semester when we make some videos, because they have a nice podcast video recording space for editing there. Okay, so we've been thinking a lot about the common Western music notation in sort of general terms. Now I want to think about a little bit computer representations. I don't know why I didn't write the word computer representations. And again, these are slides that I'm borrowing from a composition package named Belle Bon Sage, exactly the named after that piece in the shape of the heart things. So we talked about this extremely fast on day one, but I want to slow down a little bit more. The two main ways that people have chosen generally to encode common Western music notation for the computer are in terms of the container-based thing, the box-based. So you have a big box that might be the whole score, some kind of a thing, and then you have smaller boxes that that might be parts. Within those, you have measures, and quite often voices become things inside that, and then going all the way down to notes. So this representation. The other second one that is very common is the time sliced based container. So everything that happens at a certain moment in musical time is in its own slot. Some people would not put these in 3 different slots because, or these 4 things in 4 different slots because all of these things happen musically at time 0, right? The clef, there is no note or anything that, there's no conceptual notion that the clef comes first and then the time signature, then the key signature comes, then the time signature comes, then the first note, except that we have to write them in certain order on notation. But all of them are present at the very beginning of the score. So I want to start talking about some of the reasons why you might want to use one of these and why they're all bad choices. Every choice you make is going to be a bad choice at some point. So thinking about the part-based representation, you can immediately see certain problems. Anyone know an osseous staff, what you use that for? Can somebody explain that? Adam, I think we've been really great, but I want to hear a few more voices right now. Anyone ever heard that term, osseous staff? No. It's a little staff. Right? No. Pianists, violinists see it quite often, especially when you're starting, when you're playing a concerto signs in a really hard part. No. Yeah, Hannah.
Is it an alternative way to play that measure?
Yes, it's an alternative way to play that measure. This is a hypothetical one because I don't think that would ever be an alternative way to play this. But quite often, if it goes too high, for some people, especially for singers, actually singers see osseous a lot because if something's not in your voice range, sometimes they'll write a different part. Yeah, so you have a staff that just appears for a minute. We said that our top level thing might be the parts. Beyond that, sometimes for a piano thing, you might have the part and then staff 1 and staff 2. But here we have a staff that just comes up. And if everything is in a box and one of the lowest boxes is a measure, you have these problems. What do you do when you want to say, if everything's in a box, that a crescendo goes from the beginning to the next? How might you solve some of that computationally? When everything has to be in a box. And think of a box as like an array or a tuple. Yeah, go ahead, Gio.
Have like a flag start something in one box and then a flag that closes it in another.
Yeah, so everything could have a start and an end. Or certain things might. Maybe a note doesn't need to have a start and end. But yeah, you might have a flag for starts and ends. So there are some ways around it. Other possibilities? Anybody? Yeah, go ahead.
Maybe just put them a higher level up, like they don't belong inside measures, maybe they belong inside parts.
Yeah, so you move up one level. That's great. When you do that, that works quite often, but then you have a second problem that comes up, and don't worry, this problem was going to come up anyhow, especially once Mozart brings his 3 bands to the page. But you have maybe, here's your part, and you have your measures and things, and now you want to elevate the crescendo that went across 2 measures. You want to elevate it up to the next part. The next thing, let's assume that these are some sort of arrays, so we're putting commas then. Then you might have the problem, maybe you put it here, maybe you put it here, but suddenly the array is no longer sequential. In other words, that certain things can appear at points that are out of line. And so we sometimes call this the forward-backwards cursor. So that we're at a certain point, but we need to look back or to look forward in order to see what's happening at that point. But it's also a very good solution, and it's something that happens quite often. So 2 great solutions. Any other? It doesn't even have to be that great. Those are like the 2 industry most standard ways of getting around this. I couldn't plant a better. Okay, good. That's fine. I should have said those are 2 of the 3 great industry standard ways, and one of you would have come up with a 3rd way and invented something new. Never say that there's no more possibilities to an MIT student. Here's one of the problem that we were talking about this earlier with a time-based system, that grace notes, which take up no number of ticks in the time signature, but of course take up time to play and take up space on the page. Are they engraved? And they end up being one of the great problems of the time method. So you could say, hey, I'm great. I'm not a bagpiper, so I don't use grace notes. Bagpipers use grace notes all over the time. So I can do the time-based system. Or somebody else can say, look, my piece is forte from the beginning to end. I'm never going to have a crescendo. I don't need to worry about, I can use the part system. One of the things, this class is not computational representation, but it's computational music theory and analysis. Eventually, we're going to be diving into our representations and doing musical analysis on them, right? And there's certain things that we often like to do. We said first class, who has written a parallel fifth? Almost every hand went up. That's what we call voice leading, where we're looking at how certain chords or certain voices at one moment move to something at another. Anybody have a professor who frowned on this? Do we know it? Yeah. Overlap, they sometimes call this, where the bottom note has jumped above the place where the top note had recently vacated. In certain styles of music, it's not very idiomatic. Well, let's analyze how would we find overlap in the part-based, in the box system, in the container system. Well, we'd probably have, there's one container for this part or measure, and then there's going to be one container for the up-stemmed notes, that's a voice, one container for the down-stemmed notes. We need to know if at this moment, this note has crossed over the previous notes in the other containers. So we have to be able to jump back and forth among containers, and it's not very good to do. So the time slice. We want to look at everything that's happening here, and then everything that's happening here. And then it becomes a problem of, yes, but how does this note in the first slice relate to the second? So for voice leading problems, to jump to the conclusion there, neither system works well. They both have problems. They both have big conceptual difficulties that make voice leading one of the hard problems that always needs to be solved, specifically for music, before any deeper analysis can happen. And it means that, generally speaking, you're going to be writing a system for moving from one representation to another, from a time-wise to a box-wise, and how to move back and forth and have your system be able to have multiple representations. It's one of the major problems. Last little topic for today, and I think we're done with slides, so I can put this up, is just some of the terms that you're going to come up. Actually, two little things. I'll always make sure, because I don't like to keep anybody late. I want to cover the last item on there. You will get problem set 2 on Friday after you turn in problem set 1. It will also be a 1-week assignment. There is one reading to add on. It's about, I think, 15 pages or so, but 20 pages, but most of it's pictures. That you'll find on Canvas. It is an article by Nicholas Cook, who's one of the main people in this field, called Comparative and Computational Musicology. And it is, it's one of the foundational texts in this field. So I want you to read it. It's 18, 19 years old now, so it's a little bit out of date. You'll see some of the encoding, some of the ways of writing computer code are a little archaic now, but what it says is still really, really good. So you'll find that online, and we'll discuss that. There's certain questions to start thinking about. You don't need to write out answers to them, but maybe sketch down an answer to 1 or 2 of them so that you can be quite participatory on Friday. And if you haven't been reading very many scholarly articles, or this is your first time reading an article written for academics, I have like a little 6-minute optional video on how I read these articles. That maybe even if you are a master at, great at doing this it might still be useful to see how a professor doesn't read from the beginning to the end in one set. So if you want that, that might be particularly useful. So we have about 4 minutes for the last topic, and it's the one thing that I want, that you'll probably want to look at the outline for. I usually put the outline for you to get later, but and it's about the different music representation, some of the different terms that we're going to be using a lot. Has anybody taken more than one or a couple philosophy classes and come across this term? Philosophy class? What about in a CS class, computer science? Anybody ever see? I'm not going to ask for a definition right now unless you want to do it. Yeah, great. So ontologies are sort of this, ontology is the study, some people say, of essence, of meaning, of what it means to mean something, general. Philosophy and computer science have two slightly different definitions of ontology. So you're going to start seeing the word ontology in a lot of representations. It has to do with representation. For philosophy, and this is, I mean, really philosophy. You're getting a lot about what are the limits of something that makes something no longer something. So we did a lot of philosophical, ontological discussions in today and last class, right? What's something that we were trying to find the limits of? So it's when something is no longer something. A note, yeah. We wrote that there. So what's some of the things? When is a note one note? When is a note two notes? When is a note 6 notes? Right, we plan with that. When is common Western music notation no longer, does that apply? I kind of, did the frog boiling in hot water trick, like kind of slowly moving out until finally it's like, wait a second, professor, that's a whole bunch of stats on a page, right? But we got there very, very slowly. How do we put a dividing line? So there's a philosophical definition, and we're going to be using that one in this class because this is also a humanities class. We're going to be thinking about those types of things. What is the limit of something? What is a note? What is if a piece of music is every note and every duration that's in there, how many notes can you get wrong and still say that you're playing, Beethoven's Hammerklavier Sonata? 10%, 5%. One note wrong, and it is not the piece. These are some of the things that the philosophical definition does. We're not going to get to the second half here, but we'll end with the computer science usage, which is also very, very cool and related. And that would be, what are all of the objects? Yeah, dyslexia. Objects, names, relationships used in a representation. So on our ontology of a file of your computer's file system might say that there are documents and there are folders. Can documents go in folders? Yes. Can folders go in documents? No. Can documents go in documents? No. Can folders go in folders? Okay, so we're starting to make some kind of representation of something. Can a document appear twice somewhere in your hard drive? Different operating systems, yes, no, there are ways of doing it. So these are all the decisions that make up the systems and objects and representations in use. We're going to start up again on Friday by talking about some of the ontologies that we've already been creating, some of the relationships, and some of the different ways, starting to get back into programming. We haven't really done that for a little bit in class. Some of the ways that we might represent the relationships between notes and pitches and durations and so much else.